Let's try an example involving sketching polynomials. So for this example, let's let f of x equal x to the fourth minus 6x squared, and we're going to go through a few different parts here, leading us into a sketch of the polynomial. So part A, let's find the y-intercept of this function. To find a y-intercept, what we're going to do is set x equals 0. And we're going to figure out what our y value comes out to. So plugging in x equals 0 here, we get y equal to 0 to the fourth minus 6 times 0 squared. Okay, so y is equal to 0. That tells us that our y-intercept is the point where x is equal to 0 and y is equal to 0. So it's good to give that y-intercept as a point. We'll use that when we're sketching the graph a little bit later on. Part B, let's find any relative maxima. So any relative maximum points and any relative minima as well. So any relative minimum points. Well, this question is all about the derivative of our function. So let's find f prime of x will equal 4x cubed minus 12x. And to get going here, we're going to need to find any critical points. So critical points are places where f prime of x equals 0. So let's take our derivative here. 4x cubed minus 12x equals 0, and we'll have to do a little bit of factoring here to figure out what our critical points look like. So we've got a 4 common to both of these terms. We've also got a factor of x that could come out. So let's factor out that 4x. And what we've got left over is an x squared minus 3. So 4x times x squared minus 3 is equal to 0. Okay, well, we're going to get some critical points from each of these factors here. 4x is going to be equal to 0 if x is equal to 0. And x squared minus 3 equals 0 actually has two solutions. X could equal root 3, but remember it could also equal negative root 3. So we've really got plus or minus root 3 there. Okay, so that gives us 3 critical points, 0 and plus or minus root 3. Now what we're going to do is make a little chart here. Let's make a number line. Okay, we're going to put our 3 critical points on here. So we've got 0 in the middle, we've got root 3 over on the right side here, and there's our negative root 3. Now these numbers here, these critical points, these are the only places where our derivative, f prime of x, can change signs. These are the only places where our derivative can move from being positive to negative or negative to positive. So what we're going to be able to do is just test a number in each of these little intervals and figure out the behavior of our derivative. Now, for the purpose of this calculation here, it might help to grab our calculator, and let's notice that root 3 is about 1.7. That will help us figure out which numbers are the easiest to use in each interval here. So let's give ourselves a bit more space. Okay, if we look at this first interval here, from negative infinity on up to negative root 3, nicest number we could work with in this interval, probably negative 2 would be a good choice. So let's plug that into our derivative and see what happens. We're just trying to figure out, is this number positive or is it negative? So take a minute, grab your calculator, plug negative 2 into your derivative, into f prime, and check what sign you get. Comes out to a negative number. Now, here's the important thing. The critical points here, these are the only places where the derivative can change sign. So if f prime of negative 2 is negative, that tells us f prime is negative in this entire interval here. And f prime being negative in terms of our function, that means our function f of x is decreasing everywhere in that interval. That's what's really going to help us sketch the curve. Okay, so let's try this for each of our little intervals. If we go to our second interval here, let's try plugging in maybe -1. You can check using your calculator. F prime of -1 is positive. That tells us that our function is increasing everywhere in that interval. So now let's continue that process, and I'm going to just create a little bit more space for us down here so that we can organize our information a little bit better. Okay, there we go. There are 3 critical points. So for each interval, we're checking what f prime of x is doing, and we're writing down what that means for our function f of x. So in the first interval, we said f prime of x was negative. That means our function is decreasing. In the second interval, f prime of x is positive, function is increasing. If we now try, say, let's test f prime of 1, that's going to come out negative. That means our function f of x is decreasing. And then finally for this fourth interval here, let's check maybe f prime of 2 could be what we would test there. Plugging in any number in this interval here would work. So 2 is probably the friendliest number to use there. F prime of 2 comes out positive. Our function is increasing. Okay, so it's helpful to just organize this information into a little chart that looks like this. Underneath each interval, we've said what the behavior of f prime is and what that means for our function. All right, so now to answer the question about the relative maxima and relative minima. Well, we could draw a little sketch here to sort of show ourselves what's happening. Our function would be decreasing up to the x value -√3, and then it would start to increase again. So what we have here is a relative minimum. We've got a relative max when our function is increasing and then begins to decrease. And we've got another relative minimum where our function decreases and then begins to increase. So just by drawing a little sketch of what the decreasing or increasing behavior looks like, we can figure out whether it's a relative min or a relative max. Now to get the coordinates of those points. Well, the relative min happens at the x value, -√3, and to get the y value, we need to go back to our original function. That's the function that we're going to be sketching at the end of the problem. So we need the y value belonging to the function. Just plug -√3 into your function, and you can check that you get a y value of -9. Our relative maximum happens when x is 0. Again, we get the y value from going f of 0, which is 0. And our relative min, our other relative min, happens at the x value √3. To get the y value, we'll have to plug √3 into our original function, and we'll get -9. So that is part B all done.